All right, a quick review on long multiplication. In class, we've talked about doubling or having a product. We've talked about partial product. We've talked about the break apart method using a figure to show our representation. We talked about the lattice way of doing multiplication. And then, of course, the old-fashioned way, which is the way I was taught in school, and maybe your parents and grandparents also. So, starting with the double or half, I always look at the problem that we have and see if there is a number that is even. If there's a number that is even, I know I can take half of that product to make my problem a little bit easier. Now, the factor that is even is the 8. So I can break this problem down into 4 times 15 plus 4 times 15. Now, 4 times 15 is 60 and 60. That becomes 120. So I know 8 times 15 is 120. Now, some of you might be saying, I don't know what 4 times 15 is. Well, you can break it in half again. So this particular problem, 4 times 15, you could do 2 times 15 and 2 times 15. 2 times 15 is 30. And you come up with a total of 60 just for that problem. Now, if you still don't know what 2 times 15 is, you can split the 2 into 1 times 15 and 1 times 15. And that basically just becomes an addition problem. So I kept splitting my 8 because my 15 was not even. Okay, I split my 8 in half until I got to a problem that I knew. Hopefully you know what 4 times 15 is. If you don't, you can break that down into 2 times 15. Hopefully you know what 2 times 15 is. If you don't, you can go all the way down to 1 times 15. So, if you can see, this problem down here, 1 times 15 plus 1 times 15 is 30, is the same as 2 times 15. And then I take that one and I can double the 2 and get to the 4. And know that 4 times 15 is 60. And then I can take that 4 and double it and get to the 8, double my product to get to 120. This method really only works if one of your factors is an even number. Okay? If you don't have a factor that's an even number, I wouldn't even think about half or doubling as one of my ways to go about solving this problem. All right? So that is doubling or having. Now, I'll show you something real quick. On that particular problem, we determined that 8 times 15 was 120. Okay? So if you double this 8 and go to 16 times 15, all you have to do is double your product. Not really a trick. I mean, it works. But doubling one of the factors, you just double your product. And if you really want to, you can double another product. If you want to do 16 times instead of 15, say 30. Okay, I doubled this factor, so I just double my product to get to 480. And this is how kids can develop patterns and get into some bigger multiplication problems and be able to understand what the product is using mental math instead of having to write something out on a piece of paper or a whiteboard. Okay, that was doubling and half. Partial product. Okay, partial product works when your bigger factor, your 2-digit factor, is not even. Okay, so I'm going to break this 15 into, let's say, 10 and 5. And I'm going to multiply 8 times each one of them. 8 times 10, hopefully everybody knows, is 80. 8 times 5 is 40. 40 and 80 become 120. Now, you don't have to use 10 and 5. You can break it however you want. Maybe you know what 8 times 7 is. 7 and 8 are 15, so I break those two apart. 8 times 7 is 56. 8 times 8 is 64. And again, it becomes an addition problem, and you get the same product. Another way to do this is possibly you don't know anything except for your 5s, but you know your 5s really well. So instead of breaking this into 2, I might break it into 3 5s. So 8 times 5, 8 times 5, and 8 times 5. 5, 10, 15, all multiplying by 8. 40, 40, 40 becomes an addition problem. Same product. 120. All right? So, partial product, if one of your bigger factors is not even, if it's an odd one. All right. The next one, which we call break apart, is a lot like partial product. It's just that we're using a box or a rectangle to represent our two numbers. So I would draw a rectangle. The bigger or longer side would be 15. The smaller side would be the 8. And I'm going to break this 15 into something that looks proportionately right, which would be a 10 and a 5, and then do the grid. 8 times 5, 8 times 10. Add those two together, and you get the 120 product. Again, you can split this 15 up here any way you want. The break apart is really just using a box, and you're breaking the box into smaller pieces and then adding the box together to see what was all in there. That one is a good one for students who like to visually see a picture of a whole product. Lattice was a fun one that we discussed for the first time this year. Takes a little bit more work getting it set up, but the whole idea with lattice is you are doing a long multiplication problem, but you're really only multiplying a single digit times a single digit. So the kids really enjoy that one. Real simple, 8 times 15 here. I always start with a box like that, and I write my 8 times, always goes kind of diagonal with the corner of the box, and then your second factor goes down along the side. However many factors you have down the side, that tells you how many rows you have. However many factors you have on the top tells you how many columns you have. So I only have 2 boxes because I only have 2 numbers here. I only have 1 column because I only have 1 number, 1 factor up on top. The most important thing is upper right, lower left. You're dividing these boxes into diagonals, and then it becomes a grid problem again. 8 times 1 is 0, 8. Don't need to fill that 8 in, or that 0 in, but if you leave it blank, you might think you forgot something. So 0, 8, and 8 times 5 is 40. And then probably the most difficult thing with lattice is adding the diagonals. So this diagonal I have a 0. These diagonals I have an 8 and a 4, which is 12, and I carry the 1. This diagonal I have 1 plus 0. So my product becomes 120. Lattice is fun. And it's challenging for the fact that you're drawing a grid that is entertaining, I guess is a good word for it. but you can throw additional numbers in here. I mean, I can put another 8 there and continue my grid. Get rid of my 120 that I added here and the one that I carried. And just do some more diagonals to make these boxes and do another 8 times 1 and 8 times 5. And I'm still going to add my diagonals. Here I have a 0 still. I still have my 8, 4, and a 0, which is 12. But now I have a 1, a 0, an 8, and a 4. That is 13. And then I have a 1 up there. So going around this direction, 88 times 15 is now 1,320. So it's a fun way to do long multiplication. Again, you're multiplying 1 digit times 1 digit, but then adding your diagonals to come up with your product. Okay, drawing the box is the hardest thing. Once you develop a understanding of the box and the diagonals from upper right to lower left, lattice is fun and really easy. And those of you that don't know the old-fashioned way, it's simple to write a problem just the way it's written. I always start with the bigger factor on top and the smaller factor on the bottom, and I'm simply taking 5 times 8 right there, and I know that is 40. I carry the 4. 8 times 1 is 8 plus the 4. Okay? Now another way of looking at this old-fashioned way again is if you don't know 15 times 8, you don't feel comfortable with that, you can break that apart. I don't know if you can do it mental math or not, but you can break that apart to 10 times 8, which is something you should know. And then you can do the rest, which is 5 times 8. Okay, and you add those two together. So just another demonstration of kind of the old-fashioned way, but still breaking it apart to make it look like a multiplication mad minute. So there's 1, 2, 3, 4, 5 different ways to do long multiplication, and hopefully that comes in handy on your lesson today.